here on Earth. Next slide. And next slide, we do a lot of exercise in space, and we do a lot of nutrition. So we pay a lot of close attention to how much exercise astronauts are getting while they're in space. We like them to exercise about 2 hours a day, which is a lot. But what we found is that our astronauts are coming back from 6 months in space in pretty good shape. So I think we figured out how to prescribe just the right amount of exercise and just the right amount of nutrition as well. Okay, next slide. And if you just hit next slide a couple times, you'll see a lot of pictures, Michelle, of crew members doing research on orbit. We're doing a lot of research into how the human body changes in space and how to prevent the bad changes from happening. We've learned that we can't prevent all of them, but if we can mitigate or reduce the negative effects of spaceflight, our crew members come back in pretty good shape. And I will close with a little video that hopefully shows you a little bit more about research in space, and then open it up to questions.
Okay, so since all of you are laughing at the title of the file, I will tell you that most astronauts have a call sign. Ken's last name is Ham, so his call sign is Hawk. I'm a Yankee, so the northern part of the United States doesn't know what a ham hock is, and so somebody had to explain it to me. It's like pork knuckle, right? I don't know either, really.
I don't really know either.
Mike Fink was the youngest person in his Air Force class, and there's a show with a guy a kid that looks really young named Spanky. So his call sign, for Mike Fink, became Spanky. So that's where the title comes from. I was getting a lot of giggles here. All right.
I can imagine. I didn't think of that. Okay, I see it now.
Sorry, I should turn that earlier.
Okay, so open for questions, and there's one parting thought. You there?
I'm here. I'm just trying to move some
Okay.
stuff around so I can get you. I'm going to warn you. I'm putting you back on the screen. So
Okay.
faces up.
So that just gives you a very quick summary of what's going on. There's a lot of research yet to be done. Things that we're interested in learning more about include radiation. We'd like to learn how to prevent that damage and cancer. Things to think about for experiments that you can eventually participate in. We don't have a lot of equipment on orbit to measure health. We don't have a bone density device that can measure bone density on orbit. We can only do it on Earth. We don't have a very good way of measuring changes in blood in space. We draw blood in space, we put it in a freezer, we send it home, and we don't analyze it until months later. In fact, oftentimes the astronaut's already home by the time we get around to analyzing their blood samples from space. So if you're interested in hardware development or engineering, there's still a long ways to go in terms of analyzing how crew member health is changing while they're in space. And so with that, I'll open it up to questions.
Yes, please, speak real loud so she can hear you all the way over here.
Okay. I don't know if there is some special pharmacy or food supplement to decrease the lost bone effect in the human body.
Did you get that?
No, Sean, you're gonna have to repeat
Okay, yeah,
it.
no problem. Pharmacy or food supplements to help with the bone loss.
Okay, excellent question. We do supplement the diet with calcium and vitamin D. There is a drug, there's a class of drugs that people with osteoporosis can take. They're called bisphosphonates or alendronate. And we have tried an experiment in which we gave astronauts some pharmaceuticals that are to prevent bone loss. And that works, but it's not the only thing that works. So the drugs work alongside with exercise and nutrition. So it's almost an additive effect. One of those things alone is not enough. We don't require astronauts to take those kind of drugs because every drug has a side effect, right? Well, the weird side effect of those drugs for bone is they're good for your pelvis and your legs, but this weird side effect is it might cause your jawbone to die. That's a really weird side effect. I don't even know why that happens, but that's not very cool as a side effect.
Other questions? Speak real loud so at least I can hear you.
Is it possible for you to get superpowers if your DNA is hit by radiation?
He wants to know if it's possible to get superpowers if your DNA gets hit by radiation. I think he saw Spider-Man last week.
I don't know the answer to that question. I won't preclude it. I won't say yes or no because I don't know.
Yes, please.
If it was space, does it affect your body? Does it affect your body fat, and also what effect does it have on your brain?
The question is, does it affect your body fat? And he's wondering if there's an effect on the brain. And we do have a speaker speaking specifically about your brain in space in a couple of days. So I think I'll have you hold the brain question, but can you answer the body fat one, Liz?
I can. That's another thing. Another thing we don't have an ability to measure in space. There's not a direct effect of microgravity on body fat, but because they're exercising so much, in fact, many people exercise more in space than they do on the ground, that there is a tendency to lose body fat. However, if you were not to exercise, you get fatter faster in space than you do.
And Professor Green is going to talk about the brain in space on Wednesday. So.
Great.
Anything else? Yes, please. How much is your chance of getting cancer increased if you go into space?
You know, we don't actually know, unfortunately, mostly because of the small N, or the small number of astronauts that have been in space. I think we're about at 500 people who have ever been in space ever. And that's not really a big enough number to do a real statistical analysis. So we can't say yes or no that you're going to get cancer if you go and stay in space for a long time. Mostly because of the small numbers, but we can pretty much, we can guess that yes, there's an increased risk, but that there's increased risk depending